In this video, we're going to look at some kinematics formulae, and you may come across those both in maths and physics. So we're going to look at V equals U plus AT, V squared equals U squared plus 2AS, and S equals UT plus half AT squared. Now, S is displacement, so you may think about it as distance. U is initial velocity and V is final velocity. When we're thinking about velocity, I would like you to think about speed. A is acceleration and T stands for time. So let's have a look at some simple examples to start with. These questions are quite easy because all we need to do here is substitution. So the first formula I need to use is V equals U plus AT. Remember, AT means A times T. Okay, so I'm going to substitute. Now the value of V is 5 equals U is what I want to find, plus A, which is 1, times T, which is 3. So that's 5 equals U plus 3, so U equals 2, and that's done. Okay, now the second example is a little bit more complex because the formula is a little bit more complex. Okay, so I've got two examples in my table. I'm going to do the first one. So the value of S is 10, okay, equals U, which is what I want to find. So that's U times T, which is 1, plus a half times A, which is 2, times T, which is 1 squared. Okay, so I've taken all the values from the table. Now I need to calculate this. So 10 equals U times 1 is simply U. Add. Now we need to do indices first. So 1 squared is 1. 1 times 2 is 2. 2 times a half is simply 1. So the value of U is 9. Okay, and then for the second example, the value of S is 8. Then I've got U, which is 2, times T, which is 1, add a half times A, which is the unknown, okay, that we're trying to find, times T, which is 1 squared. So that's 8 equals 2 plus, that's a half A. Now we take away 2 from both sides, so that's 6 equals a half A. This can be written like this as well. Okay, so I need to times both sides by 2 to get rid of that fraction. So that means that the value of A is 12. Okay, and I can put the values in the table. So now let's have a look at a worded problem. A car starts from rest and accelerates at 5 meters per second squared for 200 meters. Work out the final velocity in meters per second. So let's have a look at the information that we have in our question. Okay, 5 meters per second squared, that's the acceleration. Okay, for 200 meters. Okay, 200 meters, that is the displacement, and we want to work out the final velocity, which is V. There is also one more piece of information in our question that is not that obvious to see, and that is this fact that the car, okay, starts from rest. So that means that the initial velocity is equal to 0. So now we need to decide which formula we need to use. Now notice that the first formula that we have here also includes T. We don't have T given in our question, so we can't really use this formula. And that means that we can't use the last formula either because it also has T in it. Okay, so the only formula that we can use here is that middle one here. So V squared equals U squared plus 2AS. V squared equals, now we substitute the values into our formula. U is equal to 0, so that's 0 squared plus 2 times 5 times 200. V squared equals 0 plus 2000, so V equals 2000. Now to find the value of V, we need to square root both sides, so we need to find square root of 2000, and V equals 44.721 and so on. So that is 45 meters per second to the closest whole number. Let's have a look at another one. A tram has an initial velocity of 300 meters per minute, okay? Initial velocity, so this is u. It travels a distance of 0.5 kilometers in 20 seconds, okay? It travels a distance of 0.5 kilometers, so this is s, in 20 seconds, so that is t. What is the acceleration? So that is a, we're looking for, of the tram in meters per second squared. So I've got to work out the acceleration. I've got u, I've got s, and I've got t. So now I need to decide which formula to use. Okay, I don't have v. Okay, so this formula is not very useful at the moment, and this formula is not very useful at the moment. So the formula that I want to use in this case is the last one here. Okay, now there's also a few issues when it comes to the units. Okay, notice that here the initial velocity is given in meters per minute. Okay, then the distance is given in kilometers, and then the time is given in seconds. So when it comes to the units, it's a little bit all over the place. So we need to do some tidying up and make sure that the units are consistent so that we can start actually calculating with those values. Okay, so 300, okay, this is the initial velocity, 300 meters, okay, per minute. Okay, 300 meters per minute. Okay, so that is, okay, 300 meters per 60 seconds. Okay, I'm sure that you agree with me, there's 60 seconds in 1 minute, so I can write this, okay, as 300 meters per 60 seconds. Okay, now I probably want to know what it is in 1 second. Okay, so here I'll have to divide it by 60, okay, to go from 60 seconds to only 1 second. So I have to do the same here, and that is 5. Okay, so 300 meters per minute, okay, is the same as 5 meters per second. Okay, 5 meters per second. Now 0.5 kilometers is a little bit easier to convert. We need to convert it into meters. That is 500 meters, because 1 kilometer is equivalent to 1,000 meters. Okay, so we've got the issue with the units sorted out now. So now all we need to do is substitute the values into our formula. So I've got this formula that I want to use. Okay, I'm going to put all the values that I know. So the first one is S, that is 0.5 kilometers, but remember that we want it in meters, so this is going to be 500. Okay, now U, okay, that was 300 meters per minute. Again, remember we want it in meters per second. Okay, so this is the one that we want to use. Okay, so that's 5. Okay, times time, which is 20, add a half times a, which is what we want to work out, times again time, which is 20 squared. Now we just need to calculate, so that is 500 equals 100 plus a half times a times 400, and that is 500 equals 100 plus 200a. Okay, we want to take away 100 from both sides, so that's going to be 400 equals 200a. Now we divide both sides by 200, and a equals 2. Remember, the units is meters per second squared. And one more example. So a bus travels with an acceleration of 2 meters per second squared, okay, that's the acceleration, and reaches a speed of 45 kilometers per hour in 5 seconds, okay. So this is the speed it reaches. That speed, that means this is the final velocity, so that is v, okay. In 5 seconds, that is t, okay. What was the initial velocity? So we are looking for u of the bus in meters per second. Okay, now again you can see that we have different units. So for example, acceleration is in meters per second squared. The initial velocity that we need to find is in meters per second, but this velocity here is given in kilometers per hour. So again, we want to do a conversion. Okay, so we want to convert this speed, so 45 kilometers, okay, per hour, we want to convert it into meters per second. So when you think about it, 45 kilometers per hour means that the distance of 45 kilometers is covered in 1 hour. Now, because we want to convert it into seconds, you need to think about how many seconds there are in 1 hour. So 45 kilometers, okay, is covered in 3,600 seconds, because this is how many seconds we have in 1 hour. Okay, so 45 kilometers per hour, that is 45 kilometers per 3,600 seconds. Okay, so if I want to work out what it is in 1 second, okay, I have to divide by 3,600. Okay, now that is 0.0125 kilometer. Okay, now I don't want my unit to be kilometers per second, I want meters per second. Okay, so to go from kilometers to meters, I have to now times by 1,000, because there's 1,000 meters in 1 kilometer. But again, remember that this is going to be per 1 second. So we're changing here kilometers to meters, and that is going to be 12.5. Okay, so 45 kilometers per hour is equivalent to 12.5 meters per second. Okay, so this is our final velocity. So now we need to decide which formula we want to use. Okay, now notice we don't have a displacement given in our question. Okay, so this formula is not very useful, and this formula is not very useful. So the formula that we want to use here is this one. Okay, so that's V equals U plus AT. Okay, now V, this is the 12.5 that we just worked out. 12.5 equals U, which is what we want to find, add A, which is 2, times T, which is 5. So 12.5 equals U plus 10, so U equals 2.5, and the answer is in meters per second.